Today's science is brutally reductionist in that it looks to peel back the layers, analyze individual pieces, and then operate under the assumption that knowledge of how the pieces work lead to knowledge and applications of how nature and technology actually function. While this has been quite successful historically, many of today's frontier problems look fundamentally different. They don't really arise because we don't understand the individual components. They arise because we don't fully understand how enormous numbers of components interact. So in other words, I'm going to argue in this episode that the remaining uncertainty that we look to solve as a human species, it's actually shifted from the parts to the relationships between the parts. And science as it is currently practiced is actually ill-suited for the problems that we now have. And as such, placing AI into the existing scientific paradigm is akin to placing a faster car on the wrong road. It doesn't get you to the destination any faster. In fact, it takes you away from it faster. I'm not saying all of science today is going wrong. Of course, it's not. There's a lot of great success there. The scientific method still stands. But there's a reductionist, overly simplistic view of the way that we peel back the layers, look for the individual pieces, and think that the knowledge of the individual pieces is going to get us what we want down the road. If you take a look at the problems that we're facing now in what I would call the age of complexity, that process doesn't really work that well. So I'm going to start with a discussion on how the scientific method works today, its steps. Then we'll see how it looks to place AI inside those steps to supercharge science as it's practiced today. But then I'll show you how that doesn't really attack the problems we have today and argue for a more system-level approach to using AI in science. So yes, money to science. Yes, artificial intelligence for use in science. Fund it. But I think the approach needs to change in how we go about actually doing science today.